All right, also, like I said, this will be 8.2. And this deals with graphing polynomials. All right, so we won't actually be graphing. We'll be choosing one of the 4 graphs on these problems. But before we deal with the graphing, we're going to look at zeros, x-intercepts, and turning points. So for this section, you got to remember that the degree of a polynomial is equal to the highest exponent. Okay, y'all, because I can use the degree of a polynomial to tell me what the maximum number of real zeros is, the maximum number of x-intercepts, and it'll also tell me the maximum number of turning points that the graph will have. So first off, to find the maximum number of real zeros. All right, so the degree tells me how many zeros I'll get from a polynomial, but y'all, sometimes they can be imaginary zeros. So this tells us what would be the maximum number of the real zeros. So y'all, the maximum number of real zeros is equal to the degree. So if you got a polynomial that's a degree 4, then that means the maximum number of real zeros is 4. Now, they don't all have to be real zeros, but that's the maximum number that I can have. So the maximum number of x-intercepts, well, if you remember on test 2, we seen that the x value of the x-intercepts was equal to the zeros, right? The solutions and x-intercepts were the same for the graph. So if a graph can have a maximum number of real zeros equal to the degree, then the maximum number of x-intercepts is also equal to the degree. Okay, that don't mean it'll cross the x-intercept that many times. That is the maximum number that it could, okay? And then the maximum number of turning points. All right, y'all, the maximum number of turning points is how many times that graph comes down and turns back up and vice versa. That is equal to the degree minus 1. So that is equal to the degree minus 1. Okay, so if my degrees are 5, I'll have 5 as the maximum number of real zeros. 5 would be the maximum number of x-intercepts. And then the maximum number of turning points would be 5 minus 1, which would be 4. All right, y'all. So knowing this, I'm going to go show you what kind of problems we're going to hit in this section, knowing that data right there. All right, so y'all should be seeing homework problem 1. So y'all, let's see what we get here. They want me to find the maximum number of real zeros, maximum number of x-intercepts, and maximum number of turning points. So I'm looking at f of x equals x to the 6 minus x4 plus 3. So y'all, the maximum number of real zeros we said was equal to the degree. So we just got to figure out what the degree of that polynomial is. All right, so we would put our 6 in there since that's my highest exponent. Then it's going to want to know what's the maximum number of x-intercepts.
6.
And well, think about it. Remember, the x-intercepts will be the same as the zeros on this.
6.
That'll be 6 again. And then the maximum number of turning points is the degree minus 1. So that'll be 5. All right, y'all. So y'all put that in. And then we go to the next question. Now, let's see what we get here. What do y'all got? Maximum number of real zeros for this polynomial.
10.
Yeah.
All right, I got my 10. All right, x-intercepts.
10.
10.
All right, so 10 and y'all remember those two answers will always match for you, okay? And then how about the maximum number of turning points?
Would it be 9?
I'm thinking I'm hearing a 9.
Yes, I said 9.
Okay. All righty, so y'all check that answer. Now, watch this next one. The only thing I can do to you on these problems is maybe throw them out of order. So on this one, what is the maximum number of real zeros?
2.
All righty, so y'all just watch them. They like to throw them out of order on you sometimes. X-intercepts?
2.
And then maximum number of turning points?
1.
There you go. So it's always 2, 2, 1, 3, 3, 2. It's always one number less, y'all. Good job. Now we're going to look at some graphs in this section. And if you remember, we made a chart the other day that went by the degree and the lead coefficients. So I got an f of x equals 1/5 x squared minus 2. So my degree is even because it's a 2. And my lead coefficient is positive because that's a positive 1/5. So if you remember, they're also telling you here to look at the y-intercepts. Because if we got two graphs that are similar, we'll use the y-intercept to figure out which one it is. So y'all, if that's an even degree, a positive lead coefficient, both ends should head upwards. Okay, remember we had that chart, we had 4 pictures. So even and positive, both ends would head upward. So the only one that's got both ends heading upward would be graph D on that, okay? So
You can also plug it in the calculator, correct? Because that's what I did.
oh yeah, if you plug it in the calculator. Now, watch it on some of these, because some of these, they'll have different window ranges for the X and Y values.
Right.
But yeah, this one's a 10 by 10. So yeah, plug it in and you'll get that exact picture.
Okay, thank you.
And y'all, that'd be the same thing on this one. Plug it in and get a picture. Now, on this one, that's the x to the 5. So the degree is odd on this one. And it's like it's got a 1 in front. So when it was odd degree and a positive lead coefficient, it went uphill left to right. Well, there's only one graph look like it's going uphill left to right. And that would be B. But do y'all see down here where it says all graphs are -5, 5, -50, 50? That's the window they want you to use on your calculator if you want to get the picture exact. So I'm going to show you how to do a window real quick. So remember that was -5, 5, -50, 50. So I'm going to go to my calculator. So to set the window, you press the window button up there by the y equals. And remember, my X minimum was -5, so I would put -5 there. Arrow down, whoops. Oh, I didn't like that. I used my subtraction key instead of my negative key. So let me put -5. Then I would arrow down, put 5 for the X max. Then on the Y values, I had a -50. And then a +50. Now let me go back and, oh, y'all, let me grab my equation real quick. So let me go grab my equation I need. And let me write this down. It was an X to the 5th minus X to the 4th plus the X squared plus 8. So now let me go put that back into Y equals. All right, so I had an X to the 5th. All right, let me arrow back down, minus X to the 4th. Plus the X squared. And then plus 8. So y'all, since we set our window to -5, 5, -50, 50 for the X and Y values, when we draw a graph, we should get a picture that looks exactly like what we've seen on MATLAB. So y'all see how this one's going uphill, left to right. Now, when I go to MATLAB, I can verify that it was actually the V graph, okay? So yeah, either way, you can use that table we made the other day, or come in and graph this one. So notice on this one, its window is -30 to 70. And it's a X to the 4 minus 2X to the 3rd plus 7X squared plus an X minus 23. So let's go grab that and see if that's, now we can predict this because at X4, that 4 is an even degree. And it's got a 1 in front of it, which is positive. So both ends need to go uphill. But y'all look, B and C look exactly the same. So that's where we got to figure out the y-intercept would be that last number, that -23. So we would have to figure out one of these graphs was crossing the y-axis at that -23. So that's tricky. So let's go graph it and see what we get. All right, so I'm gonna set my window. My X's were good, -5 to 5. But it said my Y minimum was -30. So I'm gonna punch in a -30. Then I'm gonna arrow down. And the Y max was a 70. All
I got
right.
a question.
Yeah, I hear you.
How do you know that the X min and X max is -5 and 5, if you don't mind?
Oh, okay, so let me show you what I'm looking at. So do you see the graph I'm looking at now on the homework page?
Yes, I do.
Look on the bottom and it says all graphs. Those 4 numbers there, they're giving you the windows. They're giving you the -5 to 5 is for the X's.
Uh-huh.
And then the -30, 70 is for the Y values.
Okay, thank you.
Yeah. And y'all, they always put it from X minimum, X maximum, Y minimum, Y maximum, okay? All righty, so we got that. So let's go put this thing in here. So I'm gonna clear this one. Ooh, these are pretty long sometimes. I had an X to the 4th minus, so let me bring that back down, minus 2X to the 3rd plus 7x squared plus the x minus 23. So these can be long to put in because polynomials have many terms on them. All right, we set our window, so let's hit graph. All right, now we want to go, we can see that's down a little bit. So let's go to this picture back here on the homework. So that looks like that would be C to me. And if you zoom in this, down here, they're telling you the Y scale, that YSCL, that means the Y scale is going by tens. So you can see I got a 10, 20, and it's a little bit past it. So that's probably about that negative 23 we were looking at, okay? So you click that, and then we're going to move on to the next one. So let me do one or two more of these. I want to show you one that's already factored. I'm going to skip this one. We'll skip that one. So let me see. I'm going to go down about number 9, it looks like. All right, so here's one factored. So let me write that. That's a x minus 2, x plus 3, and then an x minus 6. Now, y'all look at these graphs. Can you tell what these numbers are going from for the x's and the y's?
Is it 100 to negative 10?
So I'm going to use my x's from negative 10 to 10. And then for my y's, we'll go from negative 100 to 100. So if we use the same values as their graph has, we'll get one of them 4 pictures exactly. So y'all, what was that? Negative 10 to 10 on the x-axis. And then negative 100 to 100 for the y's. And I'm just looking at the graphs. I'm just looking at the graphs, getting them values, okay? So make them just one more bigger. All right, so let's go graph it and see what we get. All right, so I'm gonna go to y equals. I'm gonna clear that out. Let me put my graph in and then we'll set that window. So we had an x times parentheses x minus 2. Then I had parentheses x plus 3. And then finally parentheses x minus 6. All right, so our window, let's go to window. X's went from negative 10 to 10. So I'm going to change that to negative 10. And then go down 1, change my x max to positive 10. And it'll always go, the negative numbers will be the mins, the positive ones will be the maxes. And then y'all, y minimum, we had a negative 100. And a positive 100. Now, if you want to make it go back to a normal, just make it negative 10 to 10 for the x's and then negative 10 to 10 for the y's. All right, so we got our function in for y equals. We got a window set, so let's hit graph. All right, so I'm looking for one that sort of looks like a W. And it crosses right through the origin of my graph, right through the center. So we want to find one that looks like that W. So let's go to the homework. And y'all, the only one that looks like that looks like A. And it's also crossing right through the center. So you just pick your graph, check your answer, and be done on those, okay? So y'all, these aren't bad. You just gotta Set them windows to match their graphs, and you'll get the same exact picture every time. So y'all got questions on that? All right, that means we get into the fun stuff now. So 8.3. So these ain't bad sections. This 8.2 and 8.3, not too bad. Actually, 8.3's only got 5 problems doing the new stuff. So this section will be polynomial division. And y'all, the only polynomial division we're going to do for this whole section is what we call synthetic division. I can use synthetic division for 3 things in this class. The first thing I can do with synthetic division, I can find function values. So that'd be like finding f of 2, f of 3, and all that fun stuff. Now, if I use it to find function values, the function value is equal to the remainder. Okay, so if I use function, if I'm trying to find a function value like f of 5, when I do synthetic division, f of 5 will equal whatever my remainder is. All right. I can use synthetic division to determine. So to determine if a number is a 0 of the polynomial. Okay. Now, if that number is a 0, so if a number is a 0, then the remainder must be 0. So if I plug my number in and I do my synthetic division, I get a remainder of 0, then that means whatever number I was checking is a 0, okay? Now, if I get any other remainder than 0, then it's not. So these are the 2 things you're going to do in synthetic division for the college algebra part. Now, for the support part, we're going to do this third part, which is I can use it to find the quotient and remainder. So I can find a quotient and remainder. Now, in the support, when you find these quotients and remainders, it's important that if there are any missing terms, so if there are any missing terms, then we must use a 0 for that term. Now I'll do one of these support ones to show you what I'm talking about. But say you had a polynomial that was an x4 plus an x squared minus x plus 3. Since you have your x4 term and the x squared term, but you don't have an x3 term there, you would put a 0 for its placeholder. And y'all, I'll show you one of those when we hit it. So that's the 3 things I can use synthetic division for. So now I'm actually going to show you how to do synthetic division. All right, so let's do an example. So I'm going to sort of work out an example while I write my steps over here. So y'all, for this example, they're giving us f of x equals x to the third minus 12x squared plus 41x minus 30. They want us to find f of 1, f of -5, and f of 6. Now you also notice there's three things they're looking for on this problem. They want me to find f of 1, f of -5, and f of 6. Now, we have to do our synthetic division 3 times to get all 3 values. So first of all, we're going to start with f of 1. All right, y'all. So the first thing you're going to do, we're going to write out the coefficients of the polynomial. So I'm going to write the coefficients of the polynomial. Now, this is where if anything was missing, I would use zeros. But y'all notice, I got my x3 term, I got my x squared term, I got my x term, and I got my number. So nothing's missing. So let's write out these coefficients. We got a 1, a -12, a 41, and a -30. So y'all with me where I'm getting my coefficients? I'm just pulling down the numbers that are in this polynomial. All right, second, what I do is I draw this box. So this box is under the numbers. And over here under the last number, I'm going to box this in. In this last box, that will be our remainder. Okay. Now over here is what this we called our C. Our C is what number we're evaluating. So since we're finding f of 1, we put a 1 over here for our C. So we're going to put our C. All righty. So I got my coefficients. I got my C, which is the number I'm going to evaluate each time. So now here's the process of synthetic division. The first number, you bring it straight down into the box. So bring the first number down. Now, what we got to do is figure out what number is going to go in the second column. To get the next number in the next column, we take the number we brought down, multiply by C, and put that number in the next column. So 1 times 1 is 1. So multiply the number you brought down by C and put in next column. Okay, so I had this 1 brought down and multiplied by 1, that gave me a 1. Now this column, we add the column. So add the column. So y'all, I got a -12 and 1. If I was to add that, that would give me a -11. And this is where you sort of got to watch these signs on these. All right, guess what? This number down here, I need to get the next number in my column. So this number down here, -11, now multiplies by the C to get my next column. So you got -11 times 1 is -11. So at this point, we are only just repeating the process until done. All right, 41 and a -11. That's going to give us a 30 down there. Now I need to get the next number in the last column. So this 30 we just brought down, we're going to take that 30, multiply by the 1. 30 times 1 is 30. All right, y'all. So add that together and get me a remainder of 0. So since my remainder was 0, remember, we set up here function values. The function value is equal to the remainder. So that means f of 1 equals 0. Same number I would have got if I'd have put a 1 in for all those x's. All right, y'all. So let's do this for the next one. On the next one, we're going to find f of a -5. So write our coefficients again. 1, -12, 41, and -30. So for all three of these values, our coefficients are always going to be those 4 numbers. Then I'm going to make my little upside down box and box off my remainder. All right, this time my C, since I'm finding f of -5, C will be a -5. All right, y'all, let's start the process. Remember, the first number comes straight down. Now we're going to multiply, get the next column, add that, get an answer. Multiply by the -5, get the next column, add that, get an answer. Multiply by -5, get the last column. All right, y'all, so let's see what we got. We got 1 times -5 is a -5. Now I'm getting a lot of mistakes at this point, but remember, when you add 2 negatives, it's going to stay negative. Like signs is only positive if you're multiplying and dividing. So y'all, -12 and -5.
-17.
There you go, -17. Now, -17 times -5 would give you a positive 85. All right, let's add this column. Looks like what?
126.
126. All right, so I'm going to need you on this one. 126 times -5. That's a negative something.
-630.
-630. All right, y'all. So add that together, and that'll get me my remainder. Looks like a negative something.
-633.
Oh, I'm getting 660. Let's see.
I got
Oh,
6.
Yeah, I messed up.
Y'all get -660, right?
Yes.
Okay. So that means f of -5 equals a -660. So y'all, this stuff ain't bad once you get used to that little pattern I'm doing on these. What was left? A f of 6. So here we got a 1, -12, 41, -30. We'll draw our box. And then this C was a 6. All right, y'all, bring the 1 down. Even if that's not a 1, whatever that first number is, it always just comes straight down, okay? All right, let's see what we got. 1 times 6 is 6. How about that? -12 and 6.
-6.
All right, -6 times 6 is -36. All right, so 41 and negative 36.
5.
All right, let's see. 5 times 6 is 30. And y'all look at that. Negative 30 and 30. Give me a 0. So f of 6 equals 0. Now let me ask you this. Out of these three numbers I just found, which two of these values would be zeros of my polynomial? Because y'all remember up here I said
1 and 6.
the 1 and 6, right? Because we said if a number is a 0, then that remainder would be 0. Well, y'all, this one had a 0 remainder. So 1 would definitely be a 0. And then that one we just did, 6, also a 0. So y'all know we just did synthetic division 3 times, and that's all we're going to be doing on these examples, okay? So let me let y'all get caught up on that, and then we'll flip it over. Yeah, I sort of always liked doing this stuff. It wasn't too bad, I didn't think, this synthetic division. Now let me move that back up. All right, y'all, next example. This one says, using synthetic division, determine whether the numbers are zeros of the polynomial. All righty, so they got, for this one, they want me to check -5 and 2. And then my polynomial is f of x equals 3x to the third plus 10x squared minus 19x plus 30. So these two numbers they put in front are the two numbers they want me to check on being zeros or not. And then here's my polynomial. So I'm going to start with -5. So -5 will be my first C. So let's write our coefficients, and let's see. We got the x3, we got the x squared, we got the x, we got the number. So nothing's missing. So write out your numbers: 3, 10, -19, and 30. Then I'm going to draw my little box. And y'all, the first C will be -5. All right, so first thing I'm going to do is what?
Bring down
down
the first number.
All right, now what you doing?
Multiplying 3 times -5.
There you go. So that's what, a negative.
15.
There you go. All right, your next step.
Add those two together.
Okay,
Gives you -5.
there you go.
And then you're going to multiply those and get +25.
There you go.
Add those together.
So let's see, we got
6.
6. There you go.
Multiply those together and get -30. Or, yeah, 30.
You're good.
And 0.
0 remainder. So my question is that -5 a 0 of that polynomial?
Yes. Yes.
Yes. Good job. And I think it even has you put it in the you pick one of the answers and you say yes, -5 is a 0 because the remainder was 0. And then it wants you to check the next one, which is a 2. So let's bring our numbers down: 3, 10, -19, and 30. All righty, y'all. So here we go. Once again, bring this one down. Oh, what we got? 3 times 2 would be 6.
16,
16.
32,
What'd you get?
32,
32. There you go.
13, 26,
All righty, add them up.
56.
So is 2 a 0 of my polynomial?
No.
No.
No. So what they'll do, they'll have a blank that says yes, -5 is 0 because its remainder was 0. And then it would say no, 2's not a 0 because its remainder was 56. Okay. All righty, y'all. So let's do a fun one. So this one wants to know, is 1/2 a 0 of f of x equals x to the third plus 1/2 x squared plus 5/2 x minus 3/2. Now, I know this is fractions, but it's not that bad because everybody's got the same denominator. All these fractions have a 2 on the bottom, so this one's not that bad. So let's write our coefficients, which is a 1. And let's see, I got the x squared, the x, and the number, so nothing's missing again. So I got a 1, I got a 1/2, I got a 5/2, and then I got a -3/2. So I'll draw my box again. All right, my C is a 1/2. Now, y'all, the fractions look scary, but it's not that bad. So the first thing we're going to do,
Bring down your 1.
bring down my 1. All right, so guess what? 1 times 1/2.
0.5 or half.
1.5 or 1/2. Now, I mean, if you want to, you can turn them all into decimals. It'll work the same way. So how about this, y'all? What's a 1/2 plus a 1/2?
1.
1.
There you go. Or 2/2, but 2/2 turns into a 1, so good job. Now look at this. 1 times 1/2 will give me a 1/2 again. So what would 5/2 plus 1/2 give me?
3.
3. Good job, because that'd be 5 plus 1 would be 6/2, and 6/2 turns into a 3. Good job. Now do this one. 3 times 1/2.
1.5.
Now hit math and enter twice and tell me what that fraction is.
3 over 2.
3/2.
3/2. There you go. And y'all look at that. I got a -3/2, +3/2. So my remainder is 0. So the question is 1/2 a 0 of my polynomial?
Yes.
Yes, there you go. All right, so the dog agrees too, right?
Yeah.
All right, so let me show you one that you're going to see in support. In support, it says find the quotient and remainder. And y'all, this problem they're giving me parentheses a to the third minus 9a squared plus 9 divided by a minus 4. So first, we're gonna write out my coefficients. Now notice, I got an A3 term, my A squared term. I'm missing the A term, and then I got my number. So watch what I'm doing for my coefficients. I got a 1 for the A3. I got a -9 for the A squared. Remember what I said I'd put next for the A term? Since it's missing,
0.
a 0. There you go. And then my number term is a 9. And y'all, I'll tell you a little trick. The number of coefficients that you get down here is always one more than the degree. So if the degree is a 3, you got 4 numbers down here. Up here on the one we did a while ago, we had a degree 3, so we had 4 numbers. If you add 1 to the degree, that'll give you how many numbers you got to have. All righty, now here's the thing. When it's in factored form like this,
Where did we get the last 9 from?
oh, I had 9 in my, I had A3 minus 9A squared, plus this is a 9.
Oh, okay. Thank you.
All right, you see how this A minus 4 is in factor form? When it's in factor form, C has the opposite sign than the factor. So up here, when they was doing 1/2 and the -5/2, since those weren't in factor form, the C kept the same sign. But y'all, since this A minus 4 is in factor form, my C won't be a -4, it will be a +4. Because remember, factors and zeros always had the opposite sign when we was playing with these, okay? All righty, so let's do the synthetic division and get some numbers down here.
So
So-
do we just leave off the A minus?
Yeah, that's just telling you that we're basically dividing by that factor, but all we need is the opposite sign that that number has.
Okay,
Alrighty, y'all, so here we go. We're gonna bring the first number down. So that brings down that 1. All right, next, we're going to multiply the 1 times the 4 again. So 1 times 4 is 4. All right, let's see, what's that? -9 and 4.
-5.
All right, multiply the -5 times 4.
-20.
And see that spot I needed it where that 0 was. So that gave me what, 0 and -20. All right, y'all, then my last column. So I need this number now under my 9.
-80.
Because -20 times 4 is -80. All right, y'all, so add that together, and that'll give me my remainder.
-71.
-71. All righty, so we know this is the remainder already, right? So we know the remainder is going to be the -71. What we got to do is find the quotient part of this. Well, y'all, guess what? These numbers right here, these three numbers are the coefficients of the new polynomial. So these are the coefficients of the new polynomial. And the new polynomial starts out 1 degree less than the original. So think about this. My original polynomial was an a to the 3rd minus 9a squared plus 9. So these are the new coefficients. And if it starts out 1 degree less than the original, that means this will start out as a 1a squared. So I got 1a squared minus 5a minus 20. And y'all, the remainder we said was -71. Now, in all reality, if they give you answers to choose from, they're not going to put that 1 there. So this would really be what? A squared minus 5a minus 20 remainder -71. Okay, so just remember 1 degree less than the original, and then these are always the coefficients of the new polynomial, and they start out 1 degree and go down until you get that number. Okay.
On Math Lab,
Uh-huh.
it looks a little different. Like the answers that it gives you to choose from gives you like a division at the end.
Yeah, so let me show you what there's one that does that. So what they're doing here, they're taking your quotient, which is the a squared minus 5a minus 20. And then since that's a -71, they're probably doing -71 over. Now what they put it over is what you're actually dividing by up here, which is the a minus 4. It's still got the remainder here. Now, sometimes they might do plus a -71 over a minus 4, but y'all, the bottom of the fraction is always what you're dividing by up here, okay? So let's go to one on MathLab and sort of play with this. So this would be, I'm going to share my page, and we'll play with one of these real quick. So let me save this. Oh, okay, so it wants me to close that out, actually. I think I messed it up. All right, let me bring this back up again. So that was 8.3 for support. And I'm gonna find one. There's only 3, so let me see what number 2 is doing here. No, so it must be number 3. All right, so it's my third one. So let me share my screen. Let me come back. All right, so I'm gonna write this one down real quick. So I'm showing this one is almost like what I had, ain't it? So I got an a to the third minus 8a squared plus a 1, and we're dividing that by a minus 4. Now, do y'all see how 3 of these answers got that a minus 4 on the bottom? That's because the a minus 4 is what we're technically dividing this by, okay? And then they're doing the plus and then putting negatives on top. All right, so let's see which one we get. So we're going to work this real quick. All right, y'all, so I got my problem written down. So first of all, give me my coefficients.
1,
-8.
-8, 0,
Good
and
job.
1.
Yeah, I was making sure y'all got me that 0. Good job. So what would my C be?
+4.
+4. Good job. As long as you remember that 0 and that sign's different, good job. All right, y'all. So let's see what we're going to get for a remainder. Bring the 1 down. 1 times 4 is 4, so we'll add that to our next column. -8 and a +4 gives you a -4. All right, so -4 times 4 is what? A -16. Plus that 0 is a -16. Oh, y'all, let's see. -16 times 4 is a -64. So now add them two together, we get a -63. So remember, these are my quotients again, and it's going to start 1 degree less than that a third. So I've got 1a squared minus 4a minus 16, and then it's plus my remainder, which would be the negative 63 over the a minus 4. All right, y'all, so we see what we need, so let's pray that we got that on them 4 answers, okay? All right, so we had a negative 4a minus 16, and then a negative 63, so we would actually go with a on that one. So did that make sense on those fractions?
Yes.
Okay. So yeah, y'all, there's 3 in the support doing the synthetic division, and let me see. Number 1, there don't look like there's nothing missing on it. And you would actually use a positive 6 on the one I've got up there. Number 2, you got the 3, there's 2. So the only one that had anything missing would have been the number 3 when y'all do the homework. And it'll be really similar to what I had, okay?
On number 2, do you use the -5 or just keep the +5? I think it was 1. My bad. I don't
Okay,
think
let me
it.
go to number 1.
No.
Oh, they switched it up. But since that's the R minus 6,
Uh-huh.
C would be a positive 6 on that one.
Okay, if it was a positive, do you just leave it positive?
No, if it was a R plus 6,
Uh-huh.
then you would make that a negative.
Negative. Okay, thank you.
Oh, like this one's positive 3. You see this one? S plus
Uh-huh.
3. So what are you
Mhm.
using?
A -3.
Negative 3. Okay. Good job. All right, y'all. So that is 8.3. You got, I think, 5 problems doing a little bit of synthetic division for college algebra, finding function values, and looking for zeros. You got 3 problems in support, and that's going to be the ones finding the quotients and the remainders. So y'all, I think now I'm at the point where any questions from y'all? So y'all know y'all won't be seeing me next week at all, right?
Yeah.
Right.
So here's the thing. Use next week if you're behind anything. Next week's the perfect week to get caught up if you're not sitting on the beaches or something, okay? All right, y'all, let me look on chat. I see something on chat. Let me pull that up real quick. All right, so that just says enjoy spring break. All right, you too, Jonathan. So y'all, any questions at all? If not, I'll let y'all go and I guess start y'all spring break, right?
Have a nice spring break.
All righty, y'all too. All right, y'all see no questions. So give me about an hour. I'll have this video out for you.
Thank you.
All righty, y'all have a good one.